our first speaker this morning is Mike Kilcrease. He is the operations manager at the USU Botanical Center in Kaysville, where I am located at. And we have 100 acres that Mike helps to maintain and manage, and he is an irrigation wizard. So he's going to be talking to us this morning about irrigation. Again, as he goes through his presentation, please put your comments, your questions in the Q&A, not in the chat, and he will address those toward the end of his presentation. So I'm going to turn the time over to you, Mike.
Thanks, Sheridan. Like Sheridan, my name is Mike Kilcrease. I've been at the Botanical Center for, this will be my 5th year. I also work with Seawell, Center for Water Efficient Landscaping, and we've done a few projects. There's some soil sensor projects, some native maples, some things like that. Today we're going to be talking about, I apologize, my screen just died. There we go. I apologize for that. We're going to be talking about irrigation on small scales, specifically for urban farms. And so we're going to be talking a lot about what we've done here at the Botanical Center. We have an urban farm here, and we have various different, we have raised beds, in-ground traditional, we have micro emitter heads for a small orchard, we have areas for cut flowers. So we'll go over all of the basic components. We'll start at the filter and we'll go all the way to the emitters. We'll tell you what we did here, why we chose it, and how we installed everything and how we got along with it. Okay, this is just a really nice illustration. It's just really simple. It's not really to scale. It doesn't show you exactly, but it gives you a good idea of a drip system. We've got the tubing in the ground, and then you can see it's going directly to the plant. And that's the whole purpose of a drip system. That's the whole point, is to get water where the plant needs it the most, and that's the root zone. So that's a pretty good illustration of just your basics. You got your filters, pressure reducer, valve, tubing, and then right directly to the plant. So we'll start with the filters, and that's got to be the most important part of a drip system. If you get a good filter in place, you know, some of those emitters, they're millimeters, 0.6 gallons per hour. That's a tiny millimeter to get through, and things can get clogged easy. So very first thing you need to do is you need to pick the filter, and picking the right filter. There's a couple different kinds. They have a Y filter. It would sit something like this. This is how you would install it, not necessarily straight up and down, but like this if you can. They come in all different sizes, and the sizing for you is going to be really dependent on what you have in place. 3/4, you're going to have to go with a 3/4 inch filter. You can go up, but you don't want to go down. So if you have a 1 inch, you wouldn't want to go down to 3/4. It would go up if anything, but you really want to stay right there at that 1 inch, 3/4, 1.5, whatever you've got. Most residents are going to be 3/4 or 1 inch. So that's how you're going to get your size on your filter. And then at that point, you can start talking and looking about the element on the inside. And that they have a couple different kind, mesh and micron, disc. Mesh and the micron are very similar. The disc is, you can see the difference. They're discs, they're stacked really tight, more surface area for debris to collect on. They collect on the outside, they collect as well on the inside. The discs are really well for sandy soils. The mesh and micron do a little bit better with the more plant material, mossy stuff like that. Here at the Botanical Center, we have drip in most all of our gardens, especially in the urban garden. Half of the zones in that garden are drip, so we make sure we get a good filter. This is a picture of our filter. It's a 2-inch filter. It's an amiad. This particular one has a micron in it. The filter, not the disc, and this is a brush away for cleaning. And we have a 2-inch line there, and on this particular one I use 2-inch galvanized because it's going to be out of the ground. We're not going to have to replace that very often. It's going to hold up to the weather really nice, so it's going to be there for a while. As far as taking care of those, once you get your filter, once you have the correct element on the inside, you take something. There's many different kinds. There's automatic flush aways. There's kinds that you would just flush away manually but on the bottom with a bleeder valve. This particular one, like I mentioned, is a brush away valve. You would just brush that once a week, and that's how you clean it. At the end of the season, what we do with ours, we take them all out. We put them in about a 50-50 Clorox to water and soak them. If we can, we get away with just clean them with a brush or something like that. But once you get them picked, that's kind of the maintenance on those. Pretty simple, but very important on that. Next, we're moving on to our valves, and the valve is next in line. There are several different kinds of valves, and again, a lot of this that I'm covering is just basic, really simple. What we used, because we knew what we had in place. We knew we have 1-inch poly in place, so we use what we have there, kind of keep it consistent throughout the gardens. So we went with the 1-inch inline valves. There are anti-siphon valves. There's the scrubbing valves, non-scrubbing valves. The scrubbing just gives you an extra layer of protection if you're doing drip systems. But inline valve is what we went with everything. Same kind of deal with the valves as you are with all the other components of your system. 3/4 inch, you're going to go with a 3/4 inch valve. You could go up, but you don't want to go down. 1 inch, kind of same thing all the way through. These valves, these are electric valves that I'm talking about here. These are all going to run on some kind of power, 9-volt DC power or 24-volt AC power.
Mike, I'm so sorry to interrupt you. Is
Sure.
there any way you can click the presenter view on the bottom right corner of your screen? That little next one over. Yep.
I
People are having
apologize.
trouble seeing your full size.
I apologize. Okay, how's that?
I don't think that changed anything for us. They're just having trouble seeing it because it's just not fully enlarged.
Can you just try clicking next to, the edge of where your presentation is, that, and then that should make take up the whole window? Because we're seeing your whole computer screen and not just the PowerPoint folder. If
About that.
makes sense.
I apologize. Did that change
So
it?
just with the
okay. I'm
PowerPoint one,
sorry.
if you say, I don't know.
Yeah, that's all I see to get it bigger.
Sorry, I'm going to see if I can help you.
What a pain, sorry.
I'm sorry. Let's try. Did that do anything, Ruby?
No, I'm still seeing the same thing.
Okay. That's as big as it gets on his computer.
Can
So
you,
we'll do
I
the
think
best.
though, stop your share screen and then reshare, because I think instead of just sharing the one window, it's sharing his whole screen, if that makes sense.
Yeah. So let's try share screen. I think we got it. Better?
Yes.
Okay. Sorry, Mike. I'm so sorry.
Okay, sorry about that. I'm not quite sure how far back. Oh, let's see. Back on the valves. So on the valves, what we used here, and like I was saying, we kind of keep it pretty standard. We have 1-inch poly. We don't use very much PVC around here, so we'll keep it to, we'll use 1 inch. And as you can see on this one here, you can see kind of an example of how we'll do it, because this is in a zone here where we have 3 different zones on one manifold. And you can see our drip valve on the top, because you can see the inline filter and pressure reducer. There's a valve, 1 valve, 2, 3 valves. And then we'll always put ball valves just past the manifold. That way we can just isolate and shut down if there's any maintenance that needs to be done on any, without having to shut the whole system down. And again, those are just common. You can see the wiring on there. That's just a regular 9-volt DC or 24-volt AC. And then on that, like on that last slide, you could see pressure reducers. That's kind of the next thing, the next big thing. If you're going to drip, most residents are 30 to 60 PSI. most drip systems, 25 at the very least, 40 at the most. Other than that, you're going to be blowing off the micro emitter heads. You'll get a lot of misting, and you just won't get water where you're wanting it. It's just inefficient. There's several different kinds of pressure reducers. There's the one that we can see here. This is what the last slide had as well, where you can see the pressure reducer along with there's a small filter on the end of those. So it just gives you a little bit of extra filtration on your drip zones. And it's going to reduce you down. These particular ones go down to 40 PSI. This is an inline that we'll use, that we'll put if we need a little bit of extra, or if it's in a section where we can't necessarily dig up our box to change our valve or to add additional hardware like this component here. We would put this up above ground. And I believe we have an example of one of those coming up right here. And in fact, you can see where we use that here. We have, this is in our orchard in our urban garden, and we have micro emitter heads, spray heads, and we were getting misting. And it was already reduced, but you could see where you have to sometimes reduce it down even further. And this particular one will go down to 30 PSI. And so there's several different ways, and like I've mentioned before, a lot of these components, there's several different manufacturers. There's lots of different components. Each component that I'm showing you, there are many different kinds of components. And then from there, before we get up to our emitters, I mentioned before we use PVC when we can't. Sometimes, mostly we do poly here. We do no less than 80 PSI and no more than about 100, just because the wall gets thicker, and then the wall on the poly gets thick, and then you can't put your micro emitter barbs in it. So then you have to change to a different kind of pipe once you do that. But you can see on the examples, this is pretty simple inserted barbs. And then that's just kind of what we use everywhere. We don't use too much PVC, but if we do, we'll use schedule 40 at the least. Schedule 80 if we can on larger components. It just handles more pressure, more PSI. And then you finally get up to your emitters. And at this point, there are several different kinds. In our garden, we do drip emitters. We do inline drip. We do everything in our gardens are spaced at 12 inches. They are at 0.9 gallons per hour. You can get those anywhere from 0.6 gallons an hour. That's usually on a 1/4 inch line. There's micro sprinkler heads, and those are the types that we use in our small orchard as well as our large demo orchard. There's just several different kinds. And by that time, and then you're just more worried about what plant needs. Excuse me. And then as well as another way for us for our micro emitter drip, we've built this manifold here, and we use this in a couple different places in the demonstration garden, the urban garden. And what we've done here is we've put a union in the ground, so we can take this out in the wintertime. We can just unhook everything, take it out so it doesn't overwinter. We don't get all of the weathering on it, doesn't get discolored in the sun. And then when we hook it back up, it's easy. And then each one of these are spaced at 1 foot, and then it's a 50-foot run. And the inline drip are spaced at 12 inches, and they are 0.9 gallons per hour. And that's pretty common, as I've mentioned before, throughout all of our gardens. But this is an example of how you can use a manifold. It's on one system, and you can still kind of utilize one space at a time, if that's what you're looking for. And then you can see, as I mentioned again, the micro emitters. These are the micro emitter sprays on the left, which we use in our demo garden as well as this garden. These are the ones where we were having problems. There was still just a little too much PSI, so it was misting. We weren't getting very efficient watering at all, wind blowing. So these are set on 2 gallon per hour, just with the spaghetti tube, and then they're just the micro emitters. And most of our trees around our garden, again, drip line micro emitters, we will use the inline drip tube again, and we'll just use rings. And we'll put a ring around there. And again, those are spaced at 12 at 0.9 gallons per hour. And then you can kind of do that as your spaces, watering needs of your plant. And finally, we get onto the controllers. And again, I keep mentioning this. This is something there. It's almost a preference when you get into some of these, because they all do so much. There's they have Wi-Fi capability, Bluetooth capability. They are you can get the kind we have here have their own network. So if you want to spend a little bit more, you can do on that. You can go from one station all the way up 32, 48 stations. You can get as many as you need. What we use here is since we like to know lots of different products. This particular one is just a Smart Link by Weathermatic. We use these because we have 3 or 4 of them around. We actually have 4 throughout the gardens. And this is a particular one that we'll use a network on. So we can access these, shut them off, turn them on. We can, from wherever we're at, as long as we've got cell service. So these are really good as far as that goes. If you've got large areas, small areas, again, I mentioned it's almost personal preference. They have so many things out there. Most of them come with Wi-Fi or Bluetooth. In places throughout the garden where we do not have power, we're forced to use something that we really ended up liking. This just happens to be a K-Rain product. And again, all of the manufacturers make something similar. This is just a 9-volt battery operated with an app on your phone. They're really great. You can get from 1 station all the way up to 4. And then that just works the same. You set them on your clock and then just does your plant needs. And then that's pretty much, again, you can get into as much money as you like with clocks, or as little, just as long as you get something with a kind of smart controller on it that's going to help with weather stations, things like that. They're all pretty good. And I think that about does it for me. If we have questions.
All right, so Mike, there are several questions.
Okay, I figured.
So first one, why do you typically use poly versus PVC?
Other than just personal preference, it's flexible. You don't really worry as much about the thaw and freeze as you would with a really rigid PVC. It gives you a little bit, like I said, flexibility, and helps with the weather, I think.
Okay. For urban farming, is it feasible to use drip irrigation with collected rainwater, assuming you can collect enough? If so, what do you think would be the best setup to achieve that? Do you have ideas on that, Mike?
Yeah, as long as you could get, I mean, again, like I mentioned, your filter is the most important thing. If you can filter it and get your pressure up just to, as I mentioned, anywhere from 20 to 40 PSI will get your system working. As far as getting up to that PSI, I don't know, that might require a pump. I don't know if just gravity would get you quite that much pressure, but you might have to look into a pump. But filter.
Okay, and that's what I was thinking, was that you may have to install a pump, one that you can kind of adjust the pressure on at that point, unless your rainwater is up high and you have a collecting
Really
up high. Okay, Bruce is wanting to know why a 12-inch emitter spacing. He says that is huge.
You know, I think that's almost a standard. I've seen them as small as 6-inch spacing up to 18-inch spacing. And then it was just a manufacturer thing. And as far as the 12-inch, that usually works pretty good in the traditional gardening. I think we kind of run into problems when we put them in the smaller grow boxes. We either have to use more material because we have to wrap them more, to get more emitters in a certain spot. But they definitely do make them where the spacing is a little bit smaller than that.
Yeah, and I will add, if that's okay, Mike, when we run these systems, we run them for long enough where you'll see the water start to come from the emitter, and we run them long enough so that the water, that space that spot of water kind of touches the next spot of water. So
Yeah,
you can have them
exactly.
spaced farther apart. It's more about your soil texture. So how much sand or clay you have and how long you need to run that. So if you have sand, I would say you want a closer emitter spacing, but if you have clay, you can definitely hold that water and spread it out over a period of time. So with the PVC manifold that you showed with the inline drip, how many of those drip lines are you running at the same time?
Oh, it's just that varies actually with Sheridan, depending on what crop she has, what the water needs are. But we have enough pressure. You would definitely have enough pressure on any system. If you ran it by itself on its own zone, you could run all of those. And I believe there are 12 on that
Yeah, 10 or
section,
12.
I believe.
I want to say 10 or
So
12.
we can run them all. Yeah, we can run them all at the same time. We never have any pressure.
And I will say those ball valves that we have at the end of them, not all of them are on at the same time either, because depending on crop spacing, and that's why Mike did this. And it was such a brilliant thing for him to do, to give me spacing every 12 inches so that I could crop rotate and adjust my spacing for what I needed every year. So I'm not set on having tomatoes in the same place or cabbages in the same place. It gives me that flexibility. So it was a brilliant move on his part, and I can turn those ball valves on or off. So we may have, 10 or 12 lines, but maybe not all of them are running at the same time. So let's see. How much does such a complex system cost? That's a big question right now, especially with the prices of irrigation spiking.
Yeah. Last year I would have told you again, like Sheridan just mentioned, but last year I would have said it was reasonable. This year it might not be as reasonable. The price of everything has gone up significantly. But last year I think you could do, I mean, again, it depends on what you're doing. The components aren't that expensive, and especially if it was a smaller system, if you could get away with 4 or 5 valves, valves are $20 to $30 a piece. $400 or $500 really last year. I think you could have done it reasonably. This year, quite a bit more, but
Yeah.
yeah. So it's not outrageous. It's really not outrageous.
And when we put in the urban farm garden, the one that Mike showed you a lot of, the irrigation was the most expensive piece of installing that garden. So we were around, I think, somewhere between 2,000 and 2,500 for all the irrigation, clocks,
And that was
everything. But that was a couple of years ago. So Bruce would like you to give some input on greenhouse systems. You just put one in for us in our high tunnel that we're running as a greenhouse, but maybe you can give us a little more information on greenhouses and how to irrigate them, Mike.
Sure. The one that we just put in the high tunnel here, it's almost the same concept. We're looking at the same type of thing. We're filtering our water, reducing the pressure down so we're not blowing. Because in the greenhouses we're using drip irrigation PSI, even though we're using small micro emitters, they might get a little bit more water out, but we're still reducing our pressure down. So it's the same thing. Get a good filter. We run these rather than below ground or on top of the ground. Everything's above ground. There are several different. We get our stuff. Netafim is the brand, but there's several. Rainbird, everybody has something, and they just hang from the ceiling. Same exact kind of deal. We put a micro emitter in the tubing. We set those at 2 gallons per hour, and then just let the micro emitter kind of do itself. And again, run it for whatever plant needs. Pretty simple.
Yeah, and it works great. Can you suggest local places to source irrigation parts? Is there an online place that you would recommend? What are you thinking, Mike?
Just all of the local places right here. They were all pretty good. Dirk's, Sprinkler World, Mountain Land Supply. Online, I don't get a lot on online, but I have been looking just recently. It's actually called Drip Depot, and it's a really, really good source. They've got a lot of information on there, and at least you can get some prices, get you pretty good ideas.
Great. What filter do you recommend for pressurized secondary irrigation water? Is there a certain one that you would recommend, Mike?
Well, that's what we have here, and we tried different things because we like to demo them. I would suggest if you don't have one yet, you almost need to try to kind of, you don't need to, but it would really help if you could kind of filter your water a little bit and get some kind, put a towel or a rag or something over it and see what kind of material you're seeing in there. If you're seeing a lot of dirt, sand, rocky types things, then you want to go with one of those disc filters. If you're seeing more plant type material, then maybe go with one of the mesh or micron.
Okay. How does drip tape compare to poly? We haven't run drip tape here yet, but we're going to, and
We
they're
haven't,
edible.
yeah, we haven't yet, but we're going to. So the drip tape, it's just pressurized. As long as you can keep the pressure the same, which they sell different kinds out there, that the emitters, they're pressure regulated. So no matter how long your run is or the terrain that you're going over. Rainbird has one that I've been reading about lately, just kind of researching, that Sheridan said, we're going to put it in this year. We're going to try it. So we're going to have some in some different places. So drip tape, compared to the inline 1/4 inch with the micro emitters, I don't know. I think it'll be pretty interesting. I think we're going to have a little bit more flexibility with it, because if it's not exactly flat, it'll be interesting to see, but we'll see how it does.
Okay. In Laverkin, they have large particles and their filters clog really fast. If the particles pass the filter, then they clog the emitter. Any ideas or tips there?
Just I would try different kinds of the filter that I keep talking about, whether it be a disc or a micron or a mesh. Go finer material. You can go really fine. Either the micron or the mesh will go really fine. Other than that, I mean, double filters, I've heard of people doing that in some bigger farms where they have large, we have several big filters. In fact, in the urban garden here, we have a 3-inch filter, and then we have the smaller filter and that's just kind of how we did it. So filter as much as you can.
Okay. Let's see, we have time probably for one more question. And this is a good one. My last question, she says it might be a little stupid, but it's not. She's a beginner. On average, how long do you need to run the system to get an inch of water? Many plants need an inch of water a week, and I'm trying to determine on a run time to equate to that.
Okay, sorry, you were breaking up there a little bit, but I think I got it. It's just run time on your drip system, right?
Yeah, run time on your drip system.
Yeah, and I think that's just going to be just dependent on your plants and what they need, and your emitters. If you're got a 0.9 per hour emitter, you got to really just keep an eye on it, as Sheridan mentioned earlier. Kind of see where the water's saturating, see if it's touching, see if it's getting down to where your zone is. It's really something you're going to have to kind of almost watch on your own, but just pay attention to your components. If it's a 0.9 gallon per hour, then you're going to get close to a gallon an hour. 0.6, just what's appropriate there. Just watch it that way.